And now we're going to take a final look at the rest, at some of the rest of these problems on this worksheet. Okay, 22. It's not done, but it should not be that overwhelmingly difficult. Perpendicular to this line means first find the slope of this line, which is again according to the A over B approach. Okay, is the slope here is m is equal to -3 over -1, which means, of course, that is 3, which means the slope of the reciprocal, the slope of the perpendicular is -1/3 through that point. Equation of the line parallel through here, again, the slope there is a -8/15, and that is also the slope of the parallel. So it's the slope of the line through this point to -2, 3 with that -8/15 slope. 24, the equation of the line through the point of intersection of the lines and through here. So this is a system of equations between these two. Okay, and that is to find the x and y coordinate of the point of intersection, and then use that point along with 2, 1 to find the equation of the line. We'll demonstrate in the next problem some of the procedures for finding points of intersection. So here we go. Let's look at this one now. Okay. So here is a very similar problem, number 25. The equation of the line perpendicular to 4x plus y equals 1. So that means we need the slope from that. The slope of that line is -4. The slope of its perpendicular would be 1/4. And then we need to find the point of intersection between these two lines. So we write down the two equations of lines, lining up the x and y's, and effectively want to cancel out either x or y. That's going to be obtained if we force a -2 in this second equation. That is, if we multiply this whole second equation by -2, by addition we'll eliminate the x term. Okay, so the first equation is just carried down. I just pushed the 3 to the other side where it became negative. The second equation is multiplied by -2. Sending the -7 over to the other side makes it +7, but then multiplying by -2 gives it -14. Note that by adding the x terms drop out, that was our intention, and then the y terms give us 1y equals -17. Okay, to find x, we go back into either one of the original equations, replace that value of y, mainly -17, and then solve for x. So we end up doing that and find that x is equal to -44. So we're now with the objective of finding the equation of the line through -17, -44 with slope 1/4. And here it is, and that's perfectly fine. Since it didn't specify which form of the equation, that is perfectly fine to leave it in that form. 26 is one we want to look at by means of the geometry sketchpad. So let's take a look at that. 26 here again. Okay, 26. Find a point on the line 3x plus y equals 4, and equidistance from those 2 points. So I've drawn that up over here on the sketchpad. Here are my 2 points, -5, 6, and 3, 2. Here is my line, okay, which has been put in a point slope form. And then there's some point on that line, okay, such that that point is going to be at equal distance from point A and point B. So there's a couple ways in which we can do that. So I could simply construct a segment drawn from this point to A, measure its length, and likewise construct a segment from that point to B rather, and measure its length and see when they're going to be equal. So let's just kind of get things out of the way here. Okay. So this is, they're not, of course, equal at this point. And now this is just a trial and error to see when we're going to force them to be equal. And they're right about equal right there, which puts that point probably at the -1, 2 point. I'm going to slide that up and move this a little bit more just to nudge it up and see if we're getting there. I think that's probably the point. Now, from your perspective, then what you want to do is to, this is some point C, and the coordinates of that are unknown. But the coordinates of that could be, in terms of x and y, could be x comma -3x minus 4, since this is the y value. And you could find the if that is the case, then you can compute the distance between this point and A and this point and B and equate them, okay? Or you could do something else, okay? And this is where your geometry kind of comes into play, okay? I could find the perpendicular bisector of AB. So that is, in order to find a perpendicular bisector, of course, you have to find the midpoint of that segment. Okay, so let's go and do that. Select that and find its midpoint. Okay, no, it's not happening. Try it again. Okay, and then also compute the slope of that segment. So here we go. But then select the midpoint and the slope and find the equation of the perpendicular bisector. So here we go. Let's try to find the perpendicular line, and then that on that line, the perpendicular bisector, any point on the perpendicular bisector, is at equal distance from the endpoints of the segment is bisecting. But you'll notice also that that line is going to intersect with the line y equals -3x plus 4, and lo and behold, if you could find that point of intersection, and which we certainly should be, I think we'd find that that is -2, 2, which is also coincident with the point that we were looking at here. Sorry for all those menus dropping up, but here it is. See, so there it is. So ultimately, you need to find that point, which is going to be -2, 2, either by equating the distances of BC and CA using the distance formula, where C is tagged as x comma -3x minus 4, or finding the perpendicular bisector of AB and its point of intersection with the segment given there. Okay, let's return back to the other problems at hand. 26 was that problem. 27, okay, is all right. Find the equation of the line which is perpendicular to this line, which means it has its negative reciprocal slope. So that line has a slope of -2/7. So the perpendicular would have a slope of 7/2. And at the intersection of 3x minus 2y minus 8. So here we're charged with finding the point of intersection again between these two lines, which is illustrated over here. And again, the objective is to get rid of one of the variables to be able to solve for the other. By multiplying the top equation by 3, the bottom equation by -2, we're able to eliminate x, okay, solving for y, which is 1, finding x again by plugging it back into either one of the equations. So now we have that the that the point of intersection between those two lines is, in fact, negative 2, 1. And then we're trying to find the equation of the line through negative 2, 1 with slope 7/2. So I'm using the modified point slope form here. So y minus the y1 is y minus 1 over x minus the negative 2. Set equal to the slope and cross multiply, and there you have it. Okay. Number 28, the equation of a line tangent to the circle with center at 5, 3 and at 9, 7. I'm going to call on Sketchpad again for this one. Okay. And what we have here is we're going to say that the circle here, okay, is with its center at 5, 3. So I'm going to, I don't want to do that. Okay. I'm going to draw the circle reaching out to point B. Okay. Now, there's a notion of geometry. So what do I want? I want the equation of the line that goes through that point and this point up here, essentially. Okay. And so the segment then, okay, is the radius, and of course you have 2 points, so you can find this. You can find the slope, and you can find the equation of the line. Now, let me just reread this problem, because it says find the equation of the line tangent. So the line we want is not that radius line, but the tangent line. So coming back, looking at this, okay, certainly one aspect of the geometry you want to remember is that a line tangent will meet the the tangent perpendicularly. Okay, so here's the line in question. Now, how did I draw that line? Well, that line has the point 9, 7, and the slope, which is the negative reciprocal of the segment AB. So compute the slope between the 2 points A and B. Use its negative reciprocal, okay, slope as the slope of the line in question, along with the 0.97. So again, the notion is, the concept of geometry here is that a tangent, of course, can hits a circle at one point, and the tangent will always be perpendicular to the radius at that point of tangency. Okay, so that should pretty much give you the notion of how to proceed on solving that problem. So I plus that, and I trust that's what you will do now.